In this video, we are going to be continuing to solve some word problems. But in this situation, we're looking at word problems that involve a little formula, D equals RT. Okay? This is a very simple formula oftentimes used in physics. Okay? And here we have that D is for distance. Okay? And for this situation, you'll oftentimes have um, this expressed in maybe feet, miles, kilometers, inches, okay, etc. Right? Some kind of a length or a distance measurement. Okay. You also have R is equal to rate. Okay. And the rate is really the speed. Okay. You can also think of this as the speed. Okay. So, this is oftentimes expressed in some distance per amount of time. So you might have this as miles per hour. You might have it in kilometers per hour, or kph. You might have it in feet per second. Okay. Etc. Okay, you get the idea. There's some kind of a amount of distance per an amount of time. Okay, and then the last one is t. T stands for time. Okay, this one's pretty straightforward. This will just be, seconds, minutes, hours, days, etc. Right? Months, years. You get the idea. Some amount of time. Okay, pretty straightforward. Okay. One thing I will say is if you're dealing with units, make sure you keep it in the same units that you're working with. Okay. So if it says someone drives 62 miles an hour, unless they specifically request it, don't convert it over to kilometers. I don't know why you would do that, but you get the idea. Keep the same units. Okay. That's pretty important in physics. If you change up the units, all of a sudden things can get crazy, and you can have some crazy stuff happen that way. If you want to look at some interesting stories, there have been times where entire missions for NASA have gone wrong because there were different groups of people using different units, and entire missions have failed spectacularly. So if you ever want to go down a rabbit hole about interesting histories in physics, that's one to look at where different missions have failed because different usage of units. That's a fun one. But so when you're doing your problem, it's much less consequential than a $1 billion space program, but still important. So I guess let's look at a couple of examples. The first one says that Austin went for a drive in his new car. He drove at a speed of 62.5 miles per hour for 5 hours. How many miles did he drive? So with these problems, if we're dealing with these pretty simple one-step problems like this, really all that you have to do is you have to identify what you have and what you don't have. Okay, and typically you're going to solve for the thing that you don't have. Okay, so it says that he drove at a speed of 62.5 miles per hour. So we know that speed or rate, so R is going to be equal to 62.5. Okay. And we know that he drove for 5 hours. So we know that our time, T, is equal to 5 hours. So our equation is D equals RT. We have R and we have T. So we need to know D. We want to know how many miles did he drive. All right. So what we do is we take 62.5 times 5. So D is going to be equal to R times T, or 62.5 times 5. All right, probably wouldn't hurt to use a calculator on this one. So 62.5 times 5 looks like he drove a total of 312.5 miles. Awesome. The next example, we have Tammy is riding her bicycle. It says that she rides for 27.2 kilometers at a speed of 17 kilometers per hour. How many hours does she ride? Okay, so here we have that she rides 27.2 kilometers. So that'll be our distance. Okay, we can just label this for D here. Okay, at a speed of 17 kilometers per hour. So this is our rate. Okay, and we want to know how many hours does she ride. So we know our D and our R. So we have D equals RT. So D is known, R is known. We need to know T. So what we can do is we can actually just go ahead and solve for T before we plug any numbers in. Let's go ahead and divide both sides of the equation by R. These R's will cancel, and we get that T is equal to D divided by R. And we know D and R, so now we can write this as T is equal to 27.2 divided by 17. All right, so let's go ahead and do that. And they're both using kilometers per hour and kilometers. So we know that those should cancel and we're left with just time. So that means we have a total of 1.6 hours. Okay, and again, I would use a calculator for that. Alrighty. Our next one says Jessica is going for a run. She runs at a speed of 4 miles per hour for 6.4 miles. How many hours does she run? Okay, so it says she's going at a speed of 4 miles per hour. So that's our rate. Okay, our rate. And she does that for 6.4 miles. So that's our D, distance. So again, just like last time, we have our R and our D. So we've already solved for T. So we know T is equal to D divided by R. Okay. And so, because T is equal to D divided by R, we can just go ahead and plug in our values here. So we have 6.4 divided by 4. And that should give us our answer for how long she ran. And again, it looks like 1.6 hours. So there we go. Simple enough.